curve. So question 4, we are given the curve C is the equation y equals f of x, where f of x is x plus 2 cubed. So first thing we've got to do is sketch the curve. Now, whenever we sketch, we are always having to label our points of intersection. Okay, we're dealing with the repeated root here. We know there's a root at -2, but because this is a repeated root, but it's repeated root as a cubed rather than a squared, means it's going to be a point of inflection. Okay, so my first key point on here is going to be -2, and that's going to be a point of inflection. And the other point I need is my y-intercept, which will come from cubing that number at the end, which is going to be 8. So positive cubic is going to come through point of inflection at -2, and it's then going to go up and through 8. Okay, key things: shape, point of inflection at -2, and cut the y-axis at 8. Okay, part B, find f dash of x. F dash of x is obviously going to be our differential, but first thing we've got to do is we've got to get f of x into a form where we can differentiate happily. Okay, so I've got to expand all of this out. So I can expand the first bit out, so I'll have x squared plus 4x plus 4, and I can times that then by x plus 2. And I can then expand the same bit out again, and I'm going to get, when I finish, x cubed plus 6x squared plus 12x plus 8. Now I can think about doing my differential. So when we differentiate, we're going to times by the power and take one off. So I'll have 3x squared plus 12x plus 12. And that's f dash of x. Part C. We've got the straight line L is a tangent to C at the point -1, 1. Now, I want you to sketch, guys. Always want you to sketch. So we know -1, 1 is going to sit somewhere in here. Okay, so if I've got a tangent, my tangent's going to come somewhere down here, just touch the point there and go down. Now, what that gives me straight away is it gives me an idea of what the gradient's going to be, because I know the gradient's got to be positive. Okay, and I know that it's going to probably have a y-intercept at less than or around 8 as well. Okay, probably less than 8, but I've got a really good idea of what I'm aiming at now. So, for part C, we've got a tangent at the point -1, 1. So whenever I'm looking at a tangent, I need a gradient, I need a y-intercept. Okay, I can find my gradient out because my differential is my gradient function. So all I'm going to do is I'm going to find f dash of -1. So I'll put -1 through my differential. So I'll have 3 lots of -1 squared plus 12 lots of -1 plus 12. And that's going to give me a gradient of 3. Now I can go through my equation of a line formula. There's my point, this 1, 1 is my point, this 1, 1 is my point. So I'll go y -1 equals 3 lots of x plus 1. So quick rearrange, y equals 3x, we'll have 3, the add 1 comes across, so I'll have 3x plus 4. Okay, last part, part D. The straight line M is parallel to L and is also a tangent to C. Show that M has the equation of 3x plus 8. So I know that I'm going to have another line parallel to the red line, okay, somewhere that's a tangent again. So if I'm thinking about this, I'm thinking, okay, it's probably going to sit somewhere to the left-hand side of the graph, okay, to the left-hand side of that function. So that's what I'm thinking about, and let's see what we can find. So what I know the gradient. I know the gradient's got to be 3, okay, and I know that because it's parallel to this one anyway. Okay, so that means I can set my differential equation up to equal 3. So I'm going to go with 3x squared plus 12x plus 12 equals 3, and I'm going to solve my quadratic. So move my 3 to the other side. 3x squared plus 12x plus 9 equals 0. Let's just simplify this by dividing by 3. Then we can factorise, so it's just going to go x plus 1, x plus 3. So I have 2 solutions. I have a solution at -1, I have a solution at -3. Okay. Now, I've already used the solution at -1 because that's what this one was. So I'm interested in my solution at -3. So I know my point it goes through is -3 something, and I need to find out what the y-intercept is. Not the y-intercept, sorry, what the y value is of my coordinate. So I'm going to put -3 through f of x at the top. So I do need to find out what f of -3 is. Well, -3 plus 2 is -1. -1 cubed will be -1. So I will have -3, -1 as my coordinate. Finally, put that through my equation of the line formula. So I'll end up with y plus 1 equals, I know the gradient is 3, lots of x plus 3. Okay, because remember we're doing y minus y1, so minus minus 1 will be plus 1, minus minus 3 will be plus 3. Then we've just got to expand this out. Y equals 3x, we'll have 9, take away 1 will give us 8, so we can have 3x plus 8, which I'm quite happy with because that makes sense that it's going to sit, if it's parallel, somewhere around here. Okay, so I'm happy that those answers make sense. Okay, add to the fact it actually matches with what I've been asked to do. Okay, but again guys, we use sketches to make sure we can check our answers, just sense check them.